So I think like the focus for today is like sort of think about sort of AI projects that would sort of impress recruiters and also sort of not just the recruiters but anybody else who wants to sort of work with you. So that's the main focus. So my name is Aki. I'll give a quick introduction about myself. So this is me. So grew up in Sri Lanka, sort of moved to the UK for my studies. So done my PhD postdoc here. Previously, I was head of AI at a financial services firm based out of London called Main Street Partners. And I've been an advisor and fractional CTO to multiple startups right now in SF and London. So mentored and taught over 5,000 students in this space and worked with Google. Studied at Oxford and worked at MIT, etc. So some photos of me on the right hand side. So yeah, um, like been to SF a lot in the last couple of years due to work. It's an amazing city, and also SF and London. That's where I've been sort of mostly based at for the last couple of years. So thanks a lot for everyone for joining in. So what I'm going to today do is like sort of share my experiences around like what sort of projects that could sort of help you um, sort of get noticed by recruiters, right? Whether to sort of land a new job or whether to get promoted. So that's the main focus. So currently what I'm doing right now, apart from my teaching work, I run a consultancy firm called Snapdrum, where we do end-to-end AI solutions for companies like in US, in Europe. So we have like multiple clients across the region. So we sort of provide them services. Um, so so in the past, I've sort of reviewed like over 2,200 portfolios, like so whom I've sort of applied. So out of that, sort of like 8% sort of got interviews because so initial there's a screening that happens from an HR person, and after that, when you see the portfolios, um, the the issue that I see is like there are like very fancy demos, but the actual engineering thought process was not there. So obviously for early stage sort of like internship, they might be enough, but like if you really want to sort of get somebody to sort of work on high-end projects, you need to see some signal that they can think from an engineering point of view, especially sort of considering engineering sort of trade-offs and what sort of architecture decisions that they have to make. So those are the things that I really look for when I sort of look at a CV or a sort of project. So that's why we're gonna like sort of look into today, like what sort of things you need to sort of consider. So I think like there are multiple things that people may look into, but I think these four things could be quite important if you are sort of showcasing some of sort of projects within your CV. So one is problem framing. So it's very important that you start with a business impact. Like what is the actual problem that you're trying to solve? Um, like even for your personal interest projects, you need to like frame that in a way that sort of shows some sort of a problem that you may have had. So that is one of the first things because that is a hard thing to do because we can experiment with a lot of technologies, but sort of building software for actual problem that's brings a lot of value into the play. And then there's system thinking rather than just building things. If you can think about the architecture, not just the API calls, like how different components in the system would work with each other and what sort of individual responsibilities that the component might have, how would it scale, like all kinds of things you need to sort of consider a lot when you start building. So initial MVP for sure, like you get something to work, but if you won't like put that something in your CV that on your portfolio, you really need to think about like how this project to stand from an architecture point of view. And then sort of the constraints, you need to think about the trade-offs, right? Like what sort of models to think, what sort of models to pick, the efficiency side of things, accuracy side of things, like the project that you're working on. So if you like, as you may already know, like AI models tend to be like all are probabilistic. So because of that, there's the risk of hallucinations and also the risk of things breaking down in production. So you have to sort of pick and choose these sort of constraints. So like what sort of models you're going to pick. Also, there are cost element to it. Like you have to be really careful. How do you sort of like pick the right kind of model so that is feasible from a business point of view. And like very simple thing, clear documentation. So it's going to go a long way because with AI, you can do most of these really fast right now. You don't have to like sit and type a lot of things. You can sort of share your ideas and sort of generate architecture diagrams. You can do a lot of things with AI right now. So I think it would go a long way if you sort of can sort of have clear documentation for your project. If you are hosting something on GitHub, make sure to have really clean README file so that you can sort of showcase that to your potential recruiter. Um, yeah, I think these are the things that we're going to discuss today, and I'll sort of look at like a specific example that I've built yesterday, so to show that what it looks like. So I think the the first thing that you can sort of think about is like how to frame this. So this the first example is if you say like I built a chatbot using GPT-4 and you connected some APIs. So that is might not be a really good example for a project. So, but better way to write that is you could write it in a way like reduce support tickets by 40% with AI triage, and you can sort of provide the cost as well, and then you can sort of mention how much is cost per query, and then you do some user testing and you have some um, percentage rating for your satisfaction of the solution that you have built. So these kind of things go a long way because like it shows a lot of things because you thought about a problem, you came up with a solution, and then you analyze the trade-offs and you found out the results as well. So that is like a full engineering sort of pipeline. Even though this project might be very small, but you have thought about all kinds of foundational things that you need to focus on this solution that you built. So this problem framing thing is super important. Even you may not have thought about it when you first start your pet project, but make sure to think about like if you can put some metrics, put some narrative around what you built, it's gonna go a long way. This is like a simple example, but you would probably know like how you need to like frame that, like follow this kind of a structure. You start with the problem, the approach, the trade-off that you considered, and the result. So have that written down really cleanly, and if possible share your GitHub repo, like a demo like that you can connect that to, so that's be a bit more visual. But I think this could go a long way, like this problem framing part. So the next thing is thinking about system thinking. So I'm gonna like show a quick demo that I've sort of built using an A10. So this is an agent I built yesterday for another class, and we're gonna sort of reuse that. So the agent is a lead enrichment system. So what that is, it's a multi-agent system that has orchestrator agent, and you have a research agent, and you have a Google Sheet agent that sort of saves data. Um, so I'll sort of show what it does and sort of come back to this, how that sort of contributes to systems thinking. See, yeah. So NA10, so if you haven't heard about NA10, I'll give a quick introduction for NA10. So NA10 is tool that it's a low code, no code tool that helps you build automations. It's very popular with AI development work, and it helps you build the agents and multi-agent systems really fast. And like because this doesn't have much coding, it's relatively visual based. You can anybody like even without a computer science background can start building agents, and this is open source. You can run it locally if needed. They have a cloud version as well. And the other thing is that it is very AI first, I would say. It's because like they were like from get-go, they thought really hard about the agent architectures, and then you can see a lot of the AI agent patterns. You have built-in components to build. So like one example is like they're having like these kind of agent nodes, so you can sort of create them and sort of connect different components and make it a functioning agent. So this multi-agent system has three three major components. One is this orchestrator agent that sort of controls the other agents. You have a deep research agent that can do research, you can do web search, things like that. And you have a Google Sheet agent that can sort of store information to your Google Sheet. So what this agent does is this agent can, if you give name of a person, you can do some Google search, pull out the information, summarize that, and put that into a Google Sheet. So it's quite useful when it comes to sales, when it comes to any kind of a component that you need to like prepare for. Let's say if you have a meeting coming up with a set of people tomorrow and you need to quickly do some research about them and you don't want to like sort of go and research them, you just give a list of names and this agent will go and do the research for you and put that information on your Google Sheet. So like for our premise, so I'll quickly show hopefully this works because I didn't run it today. Let's say I say um, let's see who's a good person to think about me. Yes, this is I think the Google CEO. I'm gonna give it a name so as you can see. This is Sundar Pichai. It did search. Not sure if it managed to get it. It's going on a loop. Yeah, I think yeah. So this is like the agent sort of workflow. It goes through, do some research, still running, and so yeah, it's finished the run. Let's see. Yeah, so this is the information about the CEO and like the LinkedIn and the description is there. And even if I ask someone like, I mean, say Elon Musk, another entrepreneur, and if you put that name, do the research, as you can see, it is going through this list and do the deep research work. So I'll let this run. So what I'm going to try and highlight here is like having this like system components being built. You could sort of talk about this a lot, right? So you thought about sort of having different components for your system. You have orchestrator, you have a research agent, you have a Google Sheet agent. So you can talk like how we thought about having these like different kinds of functions for your system and you separated them out so you can debug them separately, you can optimize them separately. So if not everything is a very monolithic system, so that otherwise you won't be able to sort of debug very easily. And also there are some choices I made around this. Like for example, this OpenAI module has GPT 4.1 mini, very relatively cheaper model, which is enough for this. And then for this model, I've the model and I also enabled the Google search aspect. So it can sort of do research and do web search as well. So I've sort of detached that from other agents and I've only added that feature to this agent. And I've thought about having the right kind of structure for the output that's coming from this research agent. So I've enabled something called structured output. So it checks if the output is of a certain structure so that I can easily push that information to the Google Sheet without that breaking. So you need to have the name, LinkedIn, description, that information needs to be there. So it double checks. If it doesn't come through, it will do another loop to make sure that that comes in that sort of format. So this is like a Google Sheet agent that helps you sort of control the communication with the Google Sheet, and you can easily switch that with other models, other type of databases, etc. So you have to think a lot to make these kind of decisions. This agent is simple to build; it doesn't take much time, but these small decisions, including things like um, the prompt that you might write to this agent, right? So you've given this information, you are a lead route agent, your job is to infer the name of the lead, automatically research and enrich the lead data. And also things like never ask the user if they want to save, always save automatically after enrichment is complete. So you can give this very specific information to this agent. So everything is a decision that you have to make and you can sort of add that with the description of your project or in the README so that people who read this project will understand that you thought about every single component to make this system work. So putting it out in the wild, at least using with your work, it's gonna make huge difference to refine this and have like a really good project. And another thing is like this simple memory, right? So simple memory is a mechanism that we add to this agent to have the context remembered. So So you can see I've set the context window length to 10. So this part sort of controls how many interactions in the chat will be remembered by the agent. So we set it to 10. You can set it for 5, you can set it for 100. So by pick 10 because it's a pragmatic number right now. So it's with, yeah, it's good enough that it's long enough that you remember 10 interactions that you may have with the chat. It's not too long, like 100, because otherwise it lose the relevance and you get so much information, and it's also costly. So because you every time you have a conversation with the AI agent, we make LLM call, it will sort of have this like very long context. So it's very important like you think about these things and sort of have that within the system architecture. So that's the point I want to make here. So think about sort of like building things and also sort of thinking about the architecture and like small decisions like this that would help you sort of stand out. So N8N is a great tool. It doesn't require you to code, and but you can still build things and like that make this thing work. And this can be easily connected to another website. There's a URL that you can get, and this can be sort of connected to any user interface, and you can have that interaction of the chat interface on a different place. So that's what I want to highlight here. And if I go back, I think I saw a question in the chat. Is it a question? Heidi, did you build these agents in ChatGPT? No, this is N8N. So it's a tool called N8N. So it is a workflow automation tool, and I've built it from scratch. So you just go ahead and sort of add this component. So if you click here, you can add different components. This is like a like if you use Zapier in the past, it's like a workflow tool that you can sort of add things. And yeah, it's just relatively simple, like when you get started, but you can build like relatively complex systems as well. So if you really need, you can sort of use ChatGPT, but I don't know like how it's going to play out because so if you look at it, this is a massive JSON object. So if you copy this and if you put it on the chat, you can see it's a JSON object. Like everything is a JSON object. So it's like a you have nested nodes, things like that. But yeah, you can like start from scratch if you need. Like go here, start a workflow. Let's save this. Not now. You can add a step and got the chat message, you add that, and then you go ahead and add an agent here. So likewise, start building. So this is how we sort of probably build that. Hope that is helpful, Heidi. I can share more information during Q&A. Um, Yeah, so the point I want to make here is that the system thinking, right? Like you just need to think about how do you break it down and why you break it down. So like why this matters, right? So each agent it does one specific job and it's easy to debug and it's like separation of concern. Like so you have like different sort of responsibility for each agent. So that makes a lot of sense. And structured output. So we want to make sure that there are no passing errors and you have it in a loosely coupled way so that you can swap components very easily. Like if you need to change the database, if you need to change the models, you can easily change like from OpenAI to if I need to switch to Gemini, I can do that very easily. So these things matters a lot. So when you start building things, so that sort of system level thinking is something I need try my best to sort of integrate into the projects that I'm doing, and especially when I write about them. Um, and the third point, right? So which is about the constraints. So I have picked GPT-4 Mini instead of GPT-4. So these numbers are, I mean, roughly accurate, not 100%, but the general sense is that GPT-4 is much accurate compared to GPT-4 Mini, but it's a slight accuracy difference. But it's 60% cheaper. So because of that, it makes much more sense to use GPT-4 Mini unless you are looking for like this, that 3% accuracy gain. The other thing is like 10 message memory that I showed you. It's a balance. It balances cost versus context, right? So obviously you could have 5, you could have 100. So, but 10 is like a relatively good enough number for us to experiment. I mean, this is very dependent on the context, so you might need to sort of pick something that makes sense to you. But for my sort of scenario, it doesn't make sense to like keep memory much. And then autosave, like so. I think so automatically saving information in this is quite important. So I don't have to ask separately. So it within the prompt you have that information and it goes and save that in Google Sheet. So there's no back and forth, there's no conversation, so we can just directly ask the agent to like do that for us. So it's all about like thinking these sort of information. And yeah, so like think about constraints and talking about why you made those decisions is going to go a long way. The final point is the documentation side of things. Like, so this is not the only way to write this, but I try to like add this sort of information within a documentation. So as I said earlier, with AI, you could sort of document things much in an easier manner. So you'd have the problem defined like this 12 hours of manual work per week that can be sort of reduced because of this. You have architecture diagram, let's say, and then the decision that we made, like why we picked mini, the structured output, the results itself. We got 92% accuracy. Like with time, you'll see these information. So, but you need to like sort of add them to the documentation. And also like there are any like a lot of improvements that you can do to a system, like caching, A/B testing, so things like that. So you can sort of record that in the documentation itself. So I've just used AI to sort of create a documentation, which would look like this. So for the same system that I've built, so it doesn't have like a really nice sort of architecture because it's generated by Claude. But you can build like a relatively nice looking architecture diagram to sort of show how this would play out. You have the problem statement, you have the solution architecture, you have the guide on how it works, key technical decisions, and structured out like the things that we discussed, like choice between different types of models, or why you have structured output, and auto execute pattern, 10 message memory. So you have this information, agent specialization, why you had this at multiple agents, and then the results itself, implementation details, failure modes, like things like API rate limits, web search failures, Google Sheet API error. So you can write all of these down. So whoever is going to use this can use it very easily. And then the things to improve. So likewise, you can sort of write some sort of a documentation and put that on the README so that anybody who comes to use this, see this the project, we have this information. And also if it's a recruiter, will really value this because you have summarized everything, you have sort of thought about different decisions, and you have that in place. So these things go a long way as like a really good engineering practice. Um, Yeah, so I think like this is like one example on how to write something and how to not write something. So build a RAG system with LangChain and Pinecone, which is not a good enough way to write it. But better way to write it is like documentation Q&A for 500 pages. Started with 40% accuracy. Found chunking size issue, and hybrid search. Used hybrid search for 85% accuracy. $12 a month is the cost. 200 queries per day, things like that. So you can try and sort of like write this in a way, problem solving, showing the problem solving capabilities, debugging that you did, and the measurement. So this is something you probably add to like a documentation page rather than the CV. But it's really important that you summarize this information so people who look at your project would know that you've gone through a few iterations, you know how to fix problems, you know how to measure accuracy and like certain kind of metrics for your project. So this is the right way to write about sort of engineering projects, especially in the AI space, so that it goes a long way. Um, so if you're sort of working on a project and especially focusing on sort of wrapping that project up, you need to sort of think about these things. Like obviously business problem, that's how we should actually start the project, and not a fancy tech demo. So you need to start with the business problem and sort of start building using technology, especially AI, to solve that problem. So that's the best case scenario. And then having the right kind of architecture diagram and sort of thinking about cost latency and different kinds of trade-offs, and measure the results, and also have what I improved section like the future work section for your documentation. So you have all this information in one document, and you can have that sort of in the README. If you're on a GitHub repo, you can have that on the README file. So the action plan. So if you guys are building something interesting, um, or already built something, so audit one project. If it's already built, rewrite the README, and the next 30 days, build one project with all four signals that we discussed. You could try different tools like n8n, Cursor, Laravel, that could sort of, these are all AI tools that helps you build things much faster, and you can sort of use them to sort of get things at your work like automated a lot, so that you can sort of like reduce the time that you spend on those projects. So think about like repetitive things that you are sort of doing everyday work, so you can think about sort of summarizing them. Even like if you're applying for jobs, like going through job applications and finding jobs that matches you, you can do like a deep research agent that can sort of pull jobs and summarize them, put them into a document like a Google Sheet, and at the end of the day you can pick and choose and apply to them separately. So there are so many things you can do in this space, but this is like my guide on how what to do in the next week and the next 30 days. So to get to polish up the projects that you may work on, and also like build something new that could sort of showcase your expertise. Yes, so I think like we're at the 30-minute mark, but I want to like sort of leave some time for Q&A. So I think the one thing um, that I would say to take away message from this conversation is that portfolios showcase your judgment, not your API calls. So the idea is like you need to think about how to build projects that showcase your judgment, not necessarily just using OpenAI or Claude API. Because I mean, those models are super powerful. You can do really awesome things, but how do you take it to the next level? How do you sort of solve business problems, right? So what you solved, how you decided, what sort of trade-off that you considered, and how you proved it. So I think like so that's what you need to sort of think about. And so this should be the takeaway message from our conversation. Like when it comes to sort of building things that you can showcase your skill set. Yeah, and now I want to like leave some time for Q&A regarding this topic, or even like anything related to AI. Happy to sort of have a conversation.
I have a question,
Yeah,
and I apologize if you said it. Like some of the, I was distracted for a moment.
no worries.
Um, but my question, you went through, different tools,
Yeah.
and I'm wondering if in the interviews, if these different companies or maybe different types of companies are leaning towards any of the tools, would it be beneficial to say learn one over another depending upon your industry? And do you know what they are?
Yeah, I mean, it's a great question. So I think like so I would highly recommend using Cursor at the end of the day, because Cursor is a coding tool that helps you build things. Not just it helps coding, but also is one of the AI tools that sort of helps you think about how to build AI tools for a specific industry. So that's going to help you a lot and helps you code. And if you look at Meta like recently, so they are sort of initial hiring rounds right now. So they let you and probably ask you to use AI to sort of go through the initial sort of the coding rounds. So that's a sign. So I think like I don't know exactly the tool that they're using, but they're using AI-based tooling. So any type of copilot that you can sort of access should be sufficient. So and yeah, so things like Cursor, N8N is gonna go a long way. And also like this is not necessarily a tool, but a stack that you need to think about. Like especially if you are thinking about infrastructure side of things, sort of using understanding AWS really well, especially their AI stack, it's gonna help a lot because that's been used heavily by a lot of AI companies compared to the other sort of players in the market. So that's what I've seen a lot. And so the Bedrock and those kind of tools, it's going to help a lot as well. AI tool wise, I think like the more you use, the better, because I think you'll pick up certain patterns, you'll pick up certain sort of use cases, and you use UX and UI sort of components as well. So like getting sort of really AI first, it's gonna like help you think how to sort of approach this. So I think like to summarize what I said, like think about using Cursor a lot, and then AWS stack, and those gonna like help you a lot in this AI race. Yeah. Sorry, Ellen. Yeah. So unmute. Sorry.
Oh, okay, sorry. And if somebody else has a question, I can wait.
Feel free to ask. I think context. Yeah.
Okay.
Yeah.
Um, so there was a big outage lately, like airplanes and everything because AWS went down. And I was just wondering if that was big enough to be a blip in where, in people's offices and affecting companies, and if maybe that would make people go to something else.
It's a really good question. But the counter question is, what would it be? Whether it's it's just because moving from like let's say AWS to something else takes a lot of time, right? So I think like it's also not just that effort, but also the effort of maintaining that. So let's say if you build something on a different, I know like Cloudflare or something. I think Cloudflare, yeah, Cloudflare has like similar sort of offering. They're cheaper, much more like I've heard really good stuff. But my sort of counter argument is that like who's going to maintain that? So you need to find people who understand that stack, who can sort of operate that. So because of that, that sort of skill set is going to be niche and it's very expensive. So you might be struggling to sort of get people to try and maintain that. So what I'm saying is like unless like you continue to see these kind of issues happening, um, like one or two scenarios might not be enough good of a signal to say that AWS is sort of going down. And I think that's one of the biggest sort of revenue generators. And I don't see a scenario in the next couple of years at least that AWS sort of losing the game for any kind of the cloud providers unless they lose really bad for AI. I think, yeah.
Or maybe that's the direction to take the career since it's going to be impacting companies.
Yeah, yeah, yeah. That is true. Yeah.
I really appreciate you giving everyone a full presentation when uh, nobody nobody was there for you to show your face. That's why I went ahead and kept my camera on the whole time.
No, thank you very much. I appreciate that. Highly appreciate that. Like, yeah. So yeah, thanks a
Okay,
lot, Ellen.
thanks.
Um, yeah, I think, yeah, I mean, so I think if others don't have questions, I mean, we could wrap it up, but feel free to connect with me on LinkedIn. I'll put a link as well. So if you guys have any questions in this space, like more than happy to help. Just reach out if you're applying for jobs as well, like more than happy to sort of like brainstorm something that you may have. Uh, yeah, I'm based out of London, so hit me up if you're around London as well. I travel to SF as well. Would love to catch up in person. So yeah, I think thanks a lot everyone for joining, and especially Elaine, like being kind enough to switch on the camera. But yeah, I mean thanks a lot, guys. So if you guys have questions, do reach out. Yeah, thank you, guys.